Hello and welcome to REGO-FIX TechChat. My name is David McHenry. I am the Engineering and Technical Manager here at REGO-FIX USA. Today, let's talk about tool holder fretting and taper damage. We see it all the time. You see it. Well, let's talk about what it is and what damage it's doing. Tool holder fretting, or movement or witness marks that you see on the bottom of your taper, they are very common. And they're very common for a few good reasons that we'll talk about in a moment. So what actually is going on? So you take any of your tool holders, whether it be ours or a competitor's, and you look at the taper that you have on your tool holders. And a lot of people look at it and think it's commonplace that there's a small golden band or a brown line that's around the gauge point of the steep taper tool holder. They say, hey, it's got a little bit of fretting, but not a big deal. Well, what is that fretting? The fretting is actually the movement of the tool holder inside of the spindle that it generates enough heat that it actually welds onto the spindle material inside the spindle and is pulled back off, and it welds on again and it's pulled back off, and that's what leaves that golden ring around the outside. So let's take a closer look at that golden ring and see exactly what we're talking about. Here we have a tool holder that came back from a test and trial with the customer, and the customer complained about heavy chatter, had some issues, and we get it back and we see all these gold marks here along the gauge point. That tells us that, hey, yep, he had a whole lot of chatter going on with his cut, but there's a bigger issue than just that. Chatter shouldn't cause these micro welding points to occur on the tool holder taper. The only reason that can happen is the taper is actually moving inside the spindle. So let's bring up a blown up picture and we're going to show you exactly what that golden line actually is close up. Here on the screen you can see the blown up picture. This is about 90 times multiplication using our camera microscope, and you can see the gold and you can see the black coloration inside of this fretting mark. And if you look closely, you can actually see there's material that's been removed in some areas and it's been added in others. That's literally where it's left material inside the spindle or pulled spindle material off onto the tool holder itself. Either way it goes, it's a really bad situation. So how do we get out of this? I have a little fixture here that simulates what a spindle looks like on the inside. And I can take my tool holder and I can slide that in, and it lines up perfectly with the fretting marks that were on this tool holder. So what happens? How does this tool holder vibrate so violently that it actually creates heat and welds to the inside of your spindle? Well, a couple different things can happen. One, your spindle mating surface is worn. Doesn't take much. A little bit of worn surface area allows movement, creates the fretting marks, and the damage just propagates from that point on. That is probably the worst case, being that your spindle itself has worn. The good news is, as you guys know, you can hire a company to come in, they can regrind and certify your spindle. Even if it's a big plus style, this can be done in your machine without having to remove your spindle. So that's probably the worst case scenario. One of the most common scenarios that we see that cause damage like this, which actually occurred on this tool holder, is the pull stud itself is over tightened. That creates a ballooning effect on the bottom, allowing the top of the tool holder to actually wobble inside of the spindle. That's when you see marks like this. The first thing you have to do is check that pull stud, pop it loose, put it back in by hand, check your TIR, make sure it's good, then you can take it out and torque it to spec as needed. So that's another one of the reasons. The third most common reason is cleanliness. Things aren't clean. CNC machines are made to make parts, they're made to make thousands of parts day in, day out. The only problem is they have coolant, they have chips, they have dirt and debris that gets stuck up in the spindle or on the tool holders as they dry in the carousel. That dirt and debris is then transferred up inside your spindle, and it causes problem with fit of subsequent tool holders inside the spindle. It does take time, and a lot of shops actually do it, where in between shifts or in between parts, they take something as simple as a rag up inside the spindle and they wipe it out to make sure there aren't any chips. Something as simple and quick as that quick wipe out can save thousands of dollars in spindle regrinds and damaged tool holders. Well, speaking of damaged tool holders, what do I do with tool holders that have these marks? Unfortunately, you can't regrind the outside of a spindle or a tool holder like you can a spindle once it has these marks. This tool holder should no longer be used. Why is that? It has high and low spots. These high and low spots will cause problems even on an old spindle or one you've just had reground. You don't want to use tool holders with high vibration fretting marks any longer. Once you see them, it's time to change them out. That's not just a REGO-FIX issue, that is an issue for all steep taper tool holders. Now, fretting doesn't just occur on steep taper tool holders. You can also have it on HSK tool holders. The issue with these normally comes into drawbar clamping force is not pulling the tool holder in far enough. Little different application as far as the cause, but the result is the same thing. If you see high vibration fretting marks on your HSK tool holders, those shouldn't be used anymore. They should be replaced and your spindle should be inspected for any kind of damage. It's a quick overview on what tool holder fretting is, the damage it does, and what you should do with those tool holders. If you have any questions on tool holder fretting or any other topics covered here on REGO-FIX Tech Chat, please let us know. Again, my name is David McHenry. Thank you very much.